calorimetry and chemical reactions exercise. So here we have a reaction between hydrochloric acid and magnesium, and says that in an experiment to determine the heat change for this reaction, 0.158 grams of magnesium metal was combined with enough hydrochloric acid to make 100 milliliters of solution and a coffee cup calorimeter. The HCl is sufficiently concentrated, so the magnesium completely reacted. The temperature of the solution rose from 25.6 degrees Celsius degree or to 32.8 Celsius degree. Find the heat of the reaction for the balanced reaction. So this is what you need to pay attention, read up to the end, because they ask you to find the heat for the balanced reaction. And the data that we have that's over here, 0.58 grams of magnesium. And I know that this is not 1 mole like here in the balanced reaction. Do you know why you know? Because molar mass of magnesium is 24.305 grams per mole. So that means 0.158 grams. We will have 24.05 grams, 1 mole of magnesium. So I'm gonna have, let me get my calculator here. In just 1 second. I don't know if you can see my calculator. So I'm gonna have 0.158, and you're gonna divide by 24.305. 305, and you're gonna have a very small number, right? This is 0.0065 moles of magnesium. Okay, so we know that the heat of the reaction is equal the heat of solution, negative, because the heat lost by the reaction will be equal the absorbed heat by the solution. That's why here is negative. So, and the heat for the solution is the specific heat of the solution, mass of the solution, and delta T of solution. So delta T we can calculate over here right now, right? Because I have the initial temperature. So it would be the final minus initial. So we have 32.8 minus 25.6. And this gives us 7.2, right? Celsius degree. So we know the temperature over here, the delta T. We know the specific heat because it's a solution. We're going to use the specific heat for water, which is 4.184 joules per gram Celsius degree. And this is a data from a table. You don't need to memorize because I'm going to provide this. And you have access to tables, right? So in here, I need the mass. So the mass of the solution will be the mass of hydrochloric acid. It's aqueous, right? So hydrochloric acid, it's just 10 here, okay. And I know the density. I'm gonna use all the information for water, the specific heat and the density, 1 gram, 1.0 gram per milliliter. So I know that I have 1.0 grams per milliliter. So and now I'm gonna add the 0.158 grams, which is the magnesium. So the mass of the solution will be 158 grams. And we know that we have two significant figures because we have 2 over here and 3 over here, right? Now we're gonna do the second part. We're gonna calculate the heat for the solution. We have all the data. Now it's only to put everything here. So I know the specific heat. So I'm gonna start with the mass. So mass is 100.158 grams, right? And now we're gonna go to specific heat. So specific heat is the specific heat of water, because this is a solution, grams per Celsius degree. And now I'm gonna use the delta T. So delta T is 7.2 Celsius degree. So I can cut off grams Celsius, and I'm gonna have joules, which is the unit for heat. So remember, this is the heat for solution with 0.0065 moles of magnesium, not for the balanced reaction. Okay, so I'm gonna have here negative 3017 joules. Okay, so we need to calculate the heat for the balanced reaction, right? So I know that I already have moles, right? But I need here grams. Look at this. Let me just grab over here. So I need the heat for the balanced equation. So I have balanced equation give me 1 mole of magnesium, right? And I know that 0.065 moles of magnesium give me this heat over here. So it will be 3017 divided by will give me this heat for the balanced equation will give me negative 464,153.85 joules. Since I have two significant figures, remember, two significant figures, I'm gonna round this and we're gonna have negative 460,000 joules or 160 kilojoules. That's it. That's all.